Hello everyone, I'm back. So now we want to discuss about power functions. Okay. So how does a power function look like? So power function is of this format, ax to the n, okay, where a can't be 0. And you can clearly imagine that if a is 0, then the entire term actually gets perished. So that can't be the case, okay? So we need to have an a where a, or rather it's actually, it does have a value instead of 0, okay? It could be negative, there is no problem with that, but it can't be 0 precisely, okay? And n, we say, is greater than 0, and of course it's a whole number or integer, okay? Now let's see a couple of properties of that, okay? So let's say we have a power function like this where a is equal to 1, okay? Now if n is even, okay, as I said, n has to be an integer, so it could be either even, oops, sorry, it could be either even or odd, right? So let's say n is even first, okay? Then you will see what happens when n is odd. So first of all, if n is even, a positive even number, then we say that our function, whatever the function is an even function, okay? And your intuition should quickly take you back to our previous sections where I said when a function is even, it's actually symmetric with respect to the y-axis, right? Let me give you a quick reminder. If it's even, it's symmetric with respect to the y-axis. If it's odd, then it's symmetric with respect to the origin, right? Okay, so if n is even, then we say f is even as well, okay? What's the domain of this? And again, as I've said before, if you have a polynomial, your intuition should always say that all real numbers, set of all real numbers, is actually a domain. Although it doesn't look a polynomial, it's actually a monomial. So you can actually say that and use the same concept here as well. So once again, the domain is from negative infinity to infinity. That's a domain. What about the range? So the range of this is the set of non-negative real numbers. Now, why is that? If n is even, whatever you take as x, even negative numbers, because of n being even, then the output, the final output will always be positive, like this. Let's say like this, okay? Let's say our f is -1, x is -1, and let me use a different color. X is -1, and n is 2. As you can see, n is an even positive number, so it makes it positive. So our range will be the set of non-negative real numbers, okay? So it can't be negative, it will start from 0. It can be 0, so we can actually conclude that, but it will go up to infinity. It can be 0, you need to check that. That's not the general case. It could be of this format as well, where 0 is not included depending on different values. Anyway, but it has to be non-negative, okay? The range, non-negative. Let me remove this and use the term non-negative instead. Okay, Now, from this, let's see what else we can point out. Okay, so clearly, this type of function will always contain whatever your x and n is, as long as n is an even positive number. This graph will always contain -1 and 1, 0, 0, and 1, 1. And that's obvious as well. Again, as I said, even if you take a positive, or rather a negative value, as your n is an even positive number like this, it could be of this format, it will always return you a positive value. If you plug in 0 in place of x, whatever your n is, it will always give you a 0. Same goes for a positive 1 as well. So definitely, whatever your x and n is, it will always have this as long as n is an even positive integer. Okay. Okay. And excuse me. Let's check the end behavior as well. If x tends to negative infinity, what should be your f of x? If you have already imagined, your answer should be a positive infinity. And simply because I'm repeating myself, even though you will give our function a negative value, because n being a positive even integer, it will always be positive. So if x tends to negative infinity, your functional value will still be positive, and it will be very close to positive infinity. What happens if x tends to positive infinity? Again, it will reach towards that infinite line, infinity, right? Okay. Now we want to see what happens if n is an odd positive integer instead of even. Okay. Now let's write that here. N is odd positive integer. Okay. Yeah. So first of all, what happens to f? So now your f will be odd as well. So it will be symmetric with respect to the origin. Okay. Now, as it's a monomial, we can say the domain is the set of all real numbers from negative infinity to infinity. For the range, we said it has to be non-negative. It can be 0 or more, but it can't be less than that. But for this one, it can be actually the set of all real numbers as well. Simply because as your, let's try this way. So let's say this is our power function. If you take -1, and if n is an odd positive integer, you can see we are getting a negative value. So that means it can actually go to negative infinity. So all real numbers is the answer. Okay. And again, we'll have the points. And this time, -1, 1, 0, 0, and 1, 1 for the same reasons. Okay. And finally, we want to see the behavior as well. And behavior, if x tends to negative infinity, as we can go and see, find negative values this time, so this time it will actually tend to negative infinity. And whereas if x tends to positive infinity, we take our functional value to a positive infinity. So that's the end behavior from this. Okay. Next, we'll see how can we graph a polynomial using transformations. You'll see that in the next video.